हेलो डियर एस्पिरेंट्स, वेलकम टू डॉक्टर सौरव सर क्लासेस। आज हम लोग करने वाले हैं आईएसएस मतलब इंडियन स्टैटिस्टिकल सर्विस का पेपर 3 का जो एग्जामिनेशन रिसेंट हो गया उसी पेपर का सॉल्यूशन। अगर आपको हमारी तरफ से कोई क्लासेस की ज़रूरत है या डाउट क्लियरिंग सेशन, प्रीवियस क्वेश्चन सॉल्यूशन, मॉक टेस्ट, स्टडी मटेरियल, एनी ऑफ दैट, प्लीज डोंट हेजिटेट, प्लीज कॉल और व्हाट्सएप ऑन दिस नंबर. Dr. Sources himself reply to your query through WhatsApp. So let's start with question number 3C. What will we say the question number 3C? Question number 3C says define Das and Desraj estimators of population mean on the basis of a sample size of n. So how can I define? So Das and Desraj provided different approaches to estimate the population mean mu using a sample size of n. Population mean mu using sample size of n. So these estimators are particularly useful in systematical sampling and its context. Particularly useful for systematic sampling and in contexts. Where simple random sampling may not be fully appropriate. Where simple random sampling system random sampling may not be fully appropriate. May not be fully appropriate. So what is Das estimator? So the Das estimator is not a single well-defined estimator but can refer to various estimator proposed by Das in the context of symmetric sampling. For the sake of this discussion, we will focus on the Desraj estimator. Okay, Desraj estimator. And Desraj estimator is designed for symmetric sampling and it's known for its simplicity and its unbiased nature when n equals to 2. Okay, so Desraj estimator for n equals to 2 DRE Desraj estimator for n equals to 2. That means when the sample size n equals to 2, the Desraj estimator of the population mean mu is defined as follow: mu Desraj estimator, that means mu of dr equals to y1 plus y2 divided by 2, where y1 and y2 are the sample observations. Y1 and y2 sample observation, and what is the proof of unbiasedness? To show that proof of unbiasedness, to show that this Raj estimator is unbiased for n equals to 2, we need to demonstrate that the expected value of the estimator equals to the population mean mu. Okay, so let the population size be n and the population values be y1, y2 up to yn. The population mean mu is mu equals to 1 by n summation of I equals to 1 to n of yi. That means for n equals to 2, the estimator is mu cap dr equals to y1 plus y2 divided by 2. So where y1 and y2 are two sample values, so the expected values mu dr is mu cap dr is expected value of mu cap dr is e of yi plus yj divided by 2 equals to half of expected of yi plus expected yj. Okay, since yi or yj are randomly sampled from the population, so their expected values are equal to the population mean mu. That means expected value of EYI equals to EYJ equals to mu. Thus expected value of mu cap dr is half of mu plus mu, that means only mu. So sampling variance of Desraj estimator for n equals to 2 is, so this shows that the mu dr is an unbiased estimator of mu. Mu cap dr is an unbiased estimator of mu. So finding the sampling variance, now if finding the sampling variance of Desraj estimator for n equals to 2, To find the sampling variance of this large estimator, we start the definition of variance. Variance of mu cap dr equals to expected of mu cap square mu dr cap square minus of expected of mu dr mu cap dr whole square. So we already know that expected mu cap dr equals to mu. So next we need to find expectation of mu cap square dr that defines mu cap dr equals to yi plus yj divided by 2. So thus the formula mu cap dr square equals to yi plus yj by 2 whole square. So the formula is yi plus yj whole square by 4. So expanding the square, so what is the result? Yi square into 2 into yi yj plus yj square divided by 4. Okay, and so after calculating this, we can rewrite as taking the expectation of mu dr square that is equals to 1 by 4 expectation of yi square plus expectation of 2yi yj plus expectation of yj square. So because yi and yj are independent, so we have expectation of yi yj equals to expectation of yi into expectation of yj, that is equals to mu square. So thus expectation of mu cap dr square equals to 1 by 4 into expectation of yi square plus 2 mu square plus expectation of yj square. That means since EYI square equals to expectation of yj square, so we can write it as expectation of mu cap square dr equals to 1 by 4 2 into expectation of yi square plus 2 mu square. Okay, so the result is half expectation of yi square into plus half mu square. So using the definition of variance, the variance of yi equals to expectation of yi square minus mu square. So we get expectation of yi square equals to expectation of yi square equals to variance of yi plus mu square. Substituting this in the table, E mu dr square equals to half of variance of yi plus mu square plus half of mu square. That means half of variance of I, half of variance of yi plus mu square. So finally the variance estimator is variance of mu cap dr equals to expectation of mu cap dr square minus E into mu cap dr square. So that means the value is half of variance of yi plus mu square minus mu square. That means the result is half variance of yi. So for finite population, the variance of yi can be expressed as n minus n by n minus 1 s square, where s square equals to is the population variance, since is equals to 2. Since n equals to 2. So the variance of mu cap dr is half of n minus 2 by n minus 1 square equals to variance of mu cap dr. Okay, so the final result is n minus 2 divided by 2 into n minus 1 square. Okay, so this is the formula gives the sampling variance of Desraj's estimator for n equals to 2. Okay, so this is the formula. So ऐसे ही बहुत सारा वीडियो को जानकारी के लिए आप जुड़े रहिए हमारे साथ. आज के लिए इतना ही, फिर मिलते हैं नेक्स्ट वीडियो में. थैंक यू चैम्प.